if I give you the parent function is cosine x, its derivative is negative sine x. Sometimes you see it like this, d dx of cosine x is negative sine x. Perhaps the cosine graph here in red, it's easier to see if I say y equals cosine x. Perhaps it's even easier to see that the derivative here will be sine x. Again, think of yourself on a little incredible Hulk ride at Universal Studios. First of all, look at our max and min points. Our tangent lines here are horizontal. Horizontal, so y prime equals 0, or the m10, let me say m10. It's the same as y prime. The slope of this tangent line, which is the derivative, is equal to 0 there. Here, this would continue on, right? So it's going to equal 0 here. At the maximum point, we'll have a m tangent equal to 0, which means y prime equals 0 there. And remember, this continues on forever and ever. So at this maximum point here, we also have a horizontal tangent. So the slope of the tangent line equals 0, which implies, which is the same way of saying the derivative is equal to 0. If I switch the y-axis from y to y prime, I can tell you that the derivative will be 0 here, and 0 here, and 0 here. So I first find my zeros. Now, if I'm on that incredible Hulk ride, and remember, it's got little wheels above and little wheels below, and looks like some little car, and people are cheering on it. Notice that at this very point here, my steepest slope will be found right there. So most steep slope, I don't know, maybe that's -8 over 1, -100 over 1. You're going very steeply down. It's actually not that steep, but I'm just doing it as a little bit of an exaggeration. So our most negative slope will be found right there. Wherever we have our deepest tangent graph, or our most negatively sloped tangent line graph, we're going to be there. Now, as this little car goes down and then up, so now it's on this upswing here, and you know the wheels work very hard to pull that car up sometimes. Right here, our slope is going to be most positive right there, most positive slope. And so our graph is going to be up here. Look at our graph. It goes valley, mountain. And that is the negative sine graph. So I had it wrong there. The derivative of cosine is not sine, but in fact, negative sine. You can see with our graph. This is the justification for what we're doing here. We're not just pulling this out of thin air and saying, oh, it might be nice to make it the derivative of cosine negative sine. It really is. You can see on the graph. So if we're asked to find the derivative of some cosine functions, of course, here's our parent function. We know that f dash of x here is negative sine x. If I have a constant, we can think of that as pulling that out. So our derivative will be 2 times negative sine x, which of course would be -2 sine x. Remember, the constant doesn't matter, or it's not that it doesn't matter, it just comes along for the ride. So this will be negative times negative sine x. -7 times negative sine x, a negative times a negative will be a positive. So this ultimately will be 7 sine x will be our answer there. Here, think of this as a -1 times the derivative of cosine x, which will be the opposite of negative sine x, which will, of course, just be sine x is our final answer there. 9/2 cosine x, well, the derivative here, f dash of x, will be 9/2 times negative sine x, and that negative can migrate to the front there. You don't really need those parentheses. Think of this as 8/3 times cosine x, so the derivative will be 8/3 negative sine x, and we're multiplying there. Of course, that negative will migrate to the front, and we'll have -8/3 sine x. Root 3 cosine x, the derivative will be, this constant comes along for the ride, and the derivative of sine is negative, sorry, the derivative of cosine is negative sine, and of course this negative will pop out front. Negative times positive is negative. So we'll have negative root 3 sine x. You don't need those parentheses there. And of course here, we could think of this as 1 over 4 times the derivative of cosine x, which would be 1 over 4 times negative sine x, and then this negative will be brought to the front. So ultimately, we'll get negative 1 over 4 sine x. So the problems aren't so bad. The justification for why the derivative of cosine x is negative sine x, and the justification for why the derivative of sine x is cosine x is a little bit more difficult. But actually doing the problems, not hard at all.